Hello everyone, welcome to today's webinar. We are going to be tackling road remediation and reclamation. So this is a topic that I don't think we've actually done before on one of our Soft True webinars. For those of you here in the live version of the webinar, please, ask us questions, engage with us through the Q&A section of your GoToWebinar panel. We'll likely address all of those questions at the end of the webinar. So the typical objectives of reclamation, there's a few of them. So, stabilizing slope angles, maintaining or reestablishing natural drainage patterns, minimizing erosion, minimizing maintenance, and improving the visual aesthetics. And RoadEng, although we can't help with all of them, we absolutely can help with many of these. So RoadEng itself can help you reestablish the natural topography in place of that existing road that you're looking to reclaim, to restore the natural drainage patterns, and definitely to help you stabilize those slopes, both of which reduce future liability. Now, our quick agenda for the webinar today, it's mostly going to be focusing on how to set up a cross-section template. In particular, a cross-section template that allows variable cut and fill slopes, automatically adjusting to target separate features. So this could be the edge of the existing road prism, for example. We're also going to look at how to use our design time costing feature to calculate the costs, and then how to track the different material handling throughout the entire alignment. We are going to start with a pre-built terrain, which I'm sure our presenter Matt is going to mention in a moment. So we're going to dive straight into working on how to get that cross-section template set up. And that's it for me. Super short intro today. I'm going to pass it over to Matt.
All right, thanks, Aaron. So we're covering reclaiming an existing road in our webinar today. And for this, I'm using LiDAR data. So you could use a variety of different topo sources. This is a case where if you have it, an actual survey would be really nice, because with this example, what I'm going to do is basically some interpolation from the 3D surface to figure out where either side of my road prism is. So in this case, if you have an actual surveyor there saying that the edge of fill is at this location, it might give you a bit better data. But yeah, we'll jump right into it. So I've got my terrain file set up here. We're looking at my plan view. We can look at my 3D view as well. So that's our 3D view. And for our first step, I'm going to add in I'm going to delineate the edge of my prism with a new feature. So to do that, I like to look at both my plan and 3D view at once. So I'm just going to tile those vertically so I can see both. If you're just jumping into the software and haven't used the 3D view much, there's a few tricks that make it easier to work with. One that's really nice is this track mouse. I'm going to turn that on. Now I can see if I'm hovering over in my plan view, I can see where my mouse is in the 3D view and vice versa. So we're just going to start by drawing in a new feature. So I'm going to call this extent L for left. I'm going to make it a draped feature. So it's modeled but no elevation data. I'm just going to start by clicking this in. And I won't do all of this. I'll just kind of show the gist of it. It's a two-click process, so click once to add a tangent, click again to anchor the IP for that, and then continue on. So I'm going to jump back and forth between the views, scroll around, and maybe I can be a little closer in a few spots to really catch where that edge is. So we do one side, and then with another feature, I do another. So we can make a new feature by clicking Home, New Feature, or what I was doing that you can't see, I just hit Control F for a new feature. And then we can change the name. We'll make it right. And click in here. Now, I'm not going to bore you with all that clicking, so I'm just going to get rid of that, get rid of our other one, and I'm going to insert one that I've already delineated from another file. So insert file, and oops, desktop, webinar, reclamation, and prism extents. So there we have that. That's my first crack at delineating the edges of what we're dealing with. We can use these in location. I'm just going to quickly check the name. So that one's called Prism Extents 1, and our left is called Prism Extents 0. Change that to have L and R just to make it easier to keep track of later. All right, that's good. I'm going to hit save, and then I'm going to jump back over into location. That file's saving. We're opening up location, and I'm going to create a new file. I'm going to go to that file that we just saved. Oh, and I saved it right there. And we'll hit OK. Next, I'm prompted whether I want to start my alignment with a single point or base it off an existing line. We're going to go with a single point for now, and then we will use those terrain features coming up in the next few steps. Standard template, it doesn't really matter what we're using here. At this point, we are going to change that, configure that. So there's the start of our alignment. I'm going to bring that down, and I'm going to set that at the start of our road. So here I've got my default cross-section template showing up right now. I'm just going to really quickly click in an alignment that's more or less center line of the existing road. I guess I can add in that background view that we had. Just so we can see what's what. So there's that. And there's a little bit of quality issues between the DEM data that I'm using and the image that I'm using. So they don't line up perfectly, but so just clicking that in. And I'm not really concerned about my alignment for this since it's not something that we're going to be driving on. I'm more using this center line, and I'm going to tie it down to those other features that we created and use those to grade along our cross section. Now, that being said, it's not being driven on. I'm still going to use curves for that alignment. The reason for that is if we have tight corners and we're not using curves, just tangents, we can get some funny interpolation when we're modeling our cross sections. So I'm going to go to the curves tab, and our default curve is set to be a radius of 20 meters. That works for what I'm doing. I'm just going to apply the default curve to all those IPs. All right, now over here in our profile, we can see the profile. It's just a draped line at this point. It's not unique from the topography. So yeah, we're making progress. Most obvious issue at hand is that our cross-section isn't really showing us what we want to do. So let's start by configuring a couple things here. We've got reference features turned on. I'm going to add a reference feature to this. So I'm going to click plus there, turn that on. I want to see where they intersect, and I'm going to define my reference feature 1 as being a feature from that topo surface, and we'll make it left. Now this step is entirely optional. There's a few different ways you can do this, and I'll try and cover a bit of at least 2 of them. So yeah, we've got that. I'm going to add a second reference feature. I'm going to grab it as the other prism extents, and we can choose how that shows up. So that's a triangle, and this one is showing up as a triangle. We'll hit OK, and there we are. So we can see those lines that we just added in there. Now, let's change our cross section to show something a little more fitting for what we're trying to do. Let's look at somewhere where we've got, that's a good example of what's going on. We can clearly see our prism. So let's go into templates. And right now I've got the 3 templates that everyone gets when they install the software. This is not capturing what I want to do. So I'm going to click this. I'm going to click Add Template. I'll call it REC for Reclamation. And the rest of this, we want to include volumes because we are going to track our volumes. Super elevation doesn't matter, so we can turn that off if we want. We can leave it on either way. It's not going to matter for this example. And there's that. So we've got an empty template. Now to add components to that, I'm going to go on to our eLibrary. I'm going to grab all the components, just so to have it more than anything. The component I want is in the links and connectors, and I want this link offset B, so 5. We'll hit copy. We'll bring that up into our new template, paste as new. And what this is we've got a dx and a dy. That's just if we can't find the reference feature, it's going to have a x offset, so laterally from the center line. It's going to go 20 meters, and then it's going to go up 5. Just to avoid really funny numbers, I'm going to change that to 0, and looks like we're good. So now, as Aaron introduced, that we're going to have something that is a variable cut fill slope angle. Now we can move our center line, which is this attachment point, and the end of it's always going to be attached to that other feature down there. So if we drop our grade, we're in more of a cut, and a shallower cut into the existing prism. Now I want to have the same for the other side, only I want to reference the other feature. So paste as new right. Now this, it's not automatically showing what we want because we've got the wrong reference feature set here. So we'll go reference feature 2 and reference feature 2. So that's looking good. We'll hit OK. Now nothing updated. If you use the software for road design, you probably know that that's because we haven't assigned it by range yet. So we have that reclamation template that we've created. We'll click Add, and I've got it assigned for a range from ... to ... so that's going along our entire alignment. Now, if we click along this cross section, we can see that our center line is just sitting on top of the topo right now. So it's not perfectly matching the ground, and that might be fine. You might be good with that, and you can see your mass haul diagram down here. We can see some design time costing once I recost it, but I think we can improve on this by adding in its own profile. So just like we clicked in to begin with, we can click and clicked in the horizontal, we can click in a profile that's unique here as well. So we are doing that. We can keep track of our material surpluses and deficits. So if we have somewhere, well here for example, if we were just following the topo surface, our road's in a fill, and realistically if we're trying to return this to the natural drainage patterns, we should probably be cutting there. So let's drop that down. And as we can continue that cut, we're creating a surplus. So that's where you're going to have some design judgment, and you might not perfectly match the ground, but you can decide to move this up a little ways to give you a place to put that surplus material. Yeah, so the gist of this, you just continue on and you can get your cross-section to behave the way you want. Other things that we can do in there really easily is if you want a little bench, if you want to maintain ATV access or something along those lines, you can use another link, put that in to have a flat section on either side of your recontouring. You can use any other components if you want to show armor or whatnot. There are a whole bunch of components that you can choose from with that. But yeah, now one of the limitations of doing it the way I've done it is if you want to move your reference features, we could go back into our train, kind of make an educated guess on where we should be to better capture what's going on in that cross-section geometry for the extents. Or we could add another alignment in here. So let's do that. Horizontal alignment, new, and we want to base it on a feature, and let's base it on, we'll do left first. Click next. I just want this empty, so I don't care about any earthworks with this one. There we have that. I can click our profile, zoom extents, and we can shift this up. Now we can move these alignments around, and instead of in our reference features, so I should mention too, there's a few different ways to access those reference features. We can come in here. I guess I did it in my cross-section. Plan options, reference features. We can change the definition here. You can change the definition in your templates. So in here, that reference features, oh, oops, getting ahead of myself. I've got the wrong alignment active right now. I want to go back into this one. So I can go into my templates and I can change that reference feature here. Double clicking that, reference feature 1, still reference feature 1, but I can define it in here by clicking the plus and changing this to be another alignment, or I can do it in our corridor, properties, reference features, and I can say my reference feature left, I want that to actually be a horizontal alignment too. Now in this, we still need a feature. So if you had an alignment where you used an alignment where you didn't just have a center line, you'd have to choose which linear part of the road, which point code that you want to associate with that connection. We can hit that and we should be good. Hit OK. And we'll do a quick recalculate. Recalculate all and recost. There we are. So we've switched it over. Now we can jump to that, move it around, and that tie point is going to move to wherever we have that set up. I just did it really quickly, so I did this recalculate range. Recalculate range. I'm going to do it for all, recost, and then we can see the cost to do the work that's proposed here. So this after my alignment ends, it's assumed to follow the topography. I probably should go through and design it and figure out where all my material movements are and whatnot, but I think for the sake of not boring you with a bunch of clicks, the concept's there. This cost is reflecting what we have set for our ground types. So right now I've just got a single material assigned to the entire thing, and that overburden, I have it set that any cut or excavation is assumed to be $12 a cubic meter. Placing that material is $4 a cubic meter. You can adjust that to whatever values suit your operation. Haul costs in here are defined right here. It's unit cost control. In this example, that's probably not applicable. So this unit cost control, we're breaking down the material movements into categories. So here we're saying that anything with a movement of less than 150 meters is got a haul cost of $8 cubic meter kilometer, no loading cost, overhaul, so 150 to 1 kilometer. It's got a haul cost of $4 and then a loading cost of 60 cents. As you adjust these numbers, the computer's going to go through and solve for the best breakdown of this. So where you change the material or change the way you handle the material. So this isn't applicable in this case just because these numbers are representative of having a few different pieces of equipment. This is a resource road example where you probably only have an excavator, in which case it probably makes more sense to go with free haul control. And for that, you're not limited by your costs. We're just going to assign the free haul distance to be 30 meters, so a reasonable working distance for an excavator. Click update. Okay. And whoops. Oh, cancel and recalculate recost. And there might be a slight change for that. Oh, I guess not, because it's not, everything was within that free haul distance for the movements. Yeah, so that's the gist of it. I'll just jump to something that's a little more prepared. So one that I've already clicked through the entire alignment to get us the profile and figuring out what's should actually be moved where. And there we have it. So this one is this. We can take that. We can generate a output sheet. So our design. So I went to multi-plot, and let's open a book layout. NCD formatted, and there's my cross section showing up for through that. So, yeah, and then the plan view is just as you'd expect. This, where we've got a few switchbacks, we might want to twist those around, but we can get a pretty good design pretty quickly for that. So yeah, I've covered kind of two different ways to do that. The first one being just using the reference features right out of terrain. The second one being using multiple alignments. And then the third, which I haven't talked about yet, if we really wanted to, if we just wanted to figure out a linear interpolation between these 2 points, we could take those features, model them in a separate terrain, and then just do a surface calculation between the two. Calculate volumes between one surface to another and figure out how much cut and fill you'd have for the intersection of those. Yeah, but the issue with that is you lose out in the functionality of seeing your cross sections, being able to not just have a linear connection between the two, and you also lose out on the design time costing. And I should have mentioned it too, something that would be, well, depending on what level of detail you're going into with this, might be worthwhile to set up a new ground type. I didn't do this for this, but let's call it RO for existing road. And for this, I would probably consider having an expansion factor on my for my fill. So that just being that if we cut material out of the prism and pile it back on top of the inside edge, that material is probably going to expand because it's compacted in the road prism, and then where we're trying to reclaim the site, we're not going to pack it. So, yeah, that's my presentation. I guess we'll open it up for questions.
Awesome. Thanks, Matt. So just encourage everyone, you can open your, or I should say expand your GoToWebinar panel to enter in your questions. And we do have one here that we can start with. The question, can you plan the future reclamation for a proposed road? Great question.
Yeah, absolutely. I don't have one prepared for this, but it's really easy to do. So yeah, I'm not going to do it. I thought about doing it there for a second, but just because it's going to take longer than what we have. If we had a normal road prism here, we could save that as, change the extension to train. Just call, yeah, sure, we'll call it that. Then we can save the surface that we created here, and then we can go back into our the topo surface that we're working in, and we can take that new surface that we just created and merge it in. And then that's going to take your design surface merged with your original topo, and then you can basically duplicate what we just did there, only you wouldn't even have to delineate the cut and fill extents. There'd be a feature there for you that you could just follow.
Perfect. Well, thanks, Matt. So if you do have any additional questions, you can always email them over to us at support@softtree.com. And that's it for this webinar. We're on time, which is amazing. It doesn't happen too often. So thank you everyone for coming. Thanks, Matt. This video should be up on our YouTube channel probably within the next few hours. Cheers.
Thanks, guys.
Thanks for watching another SoftTree webinar. Please be sure to subscribe to our channel below or tell us that you liked the video. Thanks for watching.